Hi, so 6 months ago I 3D printed this surfboard fin and it's been working brilliantly ever since. I've seen lots of people 3D print surfboard fins and then epoxy them and cover them in fiberglass. I've seen people make them out of wood and then cover them in fiberglass as well. And I don't think that's needed, truthfully. You just need to pick the right material. So this is made from polycarbonate carbon fiber, which is little carbon fibery chunks inside of chopping board material, basically. And that is about the strongest material with the highest tensile strength. That is the key term you want, is high tensile strength. So this fin, if you try to bend it, this is me using all my might here, it doesn't really bend much. And a stiffer fin is a better fin. And you can adjust that if you want. You can make it a bit more flexible. So yeah, it's been working really well. It's I thought it would snap on maybe the first or second use, but it truthfully hasn't. You can see some fatigue at the end here. This is just from the board bag itself and not from actual use. You see some issues with the printing. There's like these slight holes in the rear, but honestly it's not had any impact. I didn't sand it down. You don't really need to sand it down, truthfully. You can cover it in epoxy and fiberglass if you want, but it doesn't add to the strength. Fiberglass and epoxy is actually weaker than polycarbonate carbon fiber, so you're off to a win. In terms of making them out of metal, I've seen some people do that, but instead when your fin breaks, it will actually rip a hole out of your surfboard and not rip apart the fin itself. So I've waited to make this video until one of my fins snaps. I made 2 of these, rode them for 6 months and twice a week for 6 months, and they've been brilliant. I recently had a friend surf my surfboard right into the sand, and that's where the fin snapped. So I want to show you what it looks like. You can see here there's a good chunk missing in the center. There we go. So the fact that it didn't snap straight along this line here, like perfectly along, means that printing it this way means it's plenty strong, and the fact that it didn't rip out a hole in my surfboard is, I think, a great win. In terms of price, it's about £50 a spool, so this fin costs about £2.50, and a pair of fins will set you back £5. Normally in a store this would cost you about 120 quid, so I think this is a great win. And truthfully, designing your own fin is half the fun, like really it is. So I'm going to show you how to do that. You need to do a few things. You need to think about what you want your surf fin to be shaped like, maybe draw it on a piece of paper and take a picture of it to upload it to your computer, and then you can get an airfoil shape online, and then you can add it to your surf fin. There's a couple key points of how this is made. Firstly, you design the fin box section, so do that first. You might need Futures or FCS or a longboard shaped fin. Design that, find a tech savvy friend and they'll be able to make that for you. And then in terms of making this hydrofoil shape, well, this wing shape, this is what I'm going to show you how to do in this video. You select a hydrofoil for here, and you can select a hydrofoil for this shape, and then you just join the two together, and then you make the end piece separately. So that's how, in general, this whole process works. So I'll show you how to do that now. So what I've done is I've designed in one of my Fusion 360 projects a Futures fin box. So I'll just drag that on, so I can use this as many times as I want, really. And I'm going to move it across so it's aligned with this corner. I believe this number needs to be 3.5. There we go. Nice. So now we've got the corner linked up. It's important that you work out that this side's the front and this side's the rear, so you know where you're working from. Next, you want to click Insert, because you want to insert an image, and you're going to look for it on your computer. I have mine saved here. Brilliant. So I've gone to a website here, which I've got. I've gone to this website here, aerotoolbox.com/NACA-4-series-airfoil-generator, and I can you can go along and create your own airfoil, download and save it from there. Once you've got that, you should be able to click there and then ensure the orientation is correct. You want to make sure that the front of the airfoil is aligned with the front of the fin box, and the rear of the airfoil, you guessed it, is aligned with the rear of the fin box. You also need to make sure that the curved bottom surface, so you're going to actually lose the curved bottom surface, just so you're aware. And you need to make sure, there you go, so it's going to fit inside of this. Okay, that's just a kind of prerequisite to make it fit correctly. I think I can get a little bit more length out of this. There we go, so I've got this nice and in line, and you just press Enter to save it there. Next, what you want to do is trace around this. So you press R for a rectangle to start a tracing sketch, and then you want to use this straight line tool. We're just going to cut the bottom piece like so. You want to ensure that you have Snap to Grid is turned on. There we go. Brilliant. And you want to make sure that it's perfectly connected to the starting point and the ending point. Then you use your squiggly line tool and you trace along the shape. I'm going to turn off Snap to Grid for this, and you just trace it as best as you can along this shape. Along this top bit, you really got to make sure it doesn't poke over this surface bit, so click there and drag it all the way down. The rear I'd recommend making a little bit thicker, just because then it's a bit stronger when you 3D print it. This top section here, you can see there, that's needs to just be flat. I need a flat green line here, okay? And then click Finish Sketch. Cool, so you've got your hydrofoil profile. Next, what you need to do is you need to insert another image of the shape of the wing that you want. So I have saved mine here, penguin shaped. Enter this one here, click the place where you want it to spawn on, rotate it round, make it the right size. There we go. I'm going to scroll out a bit, and you want to align this how you want it to be. Brilliant. So I want my wing shape to be there. Next, what you want to do is create an offset plane. This is actually quite an important step. So the thickness of your fin will contain all the way down, the thickness of your fin will be consistent all the way up to this point. So on this fin in particular, I think I made the line along here, so it tapers off in thickness towards the end. Otherwise, it will continually get thinner and thinner to the very end of your fin. You don't want that. So what I'm going to do is I'm going to place it just about there-ish. It's about 90% of the way through, maybe 85% of the way through. And then from here, you're again going to insert an image. And you're just going to do the hydrofoil once again. So I'm going to click the hydrofoil picture, enter, and there we go. So this is the kind of tricky bit. It takes a bit of fiddling about with, but essentially you want to align this airfoil shape up with the image of the wing that you've got. So there we go. You might need to fiddle about with this a little bit, but you just got to get these two aligned up. This is your friend, this squishy bit, and then moving along like this. There we go. So you want to ensure that from a top-down perspective, these 2 points are in line with each other, and that it is in line with the actual wing shape itself. Once you've got that, press Enter, and then from this plane, this orange bit, you just click Rectangle again, and then you're going to simply click Top-Down View, and you're going to trace out this wing shape once again. So I'm going to click on Canvases to expand this out, remove the first and second one so it's a bit easier to see what I'm doing. So I'm going to use the line tool again, and I'm going to have Snap to Grid turned on to get the front and rear points made. Double click to finish, and then use your squiggly line tool, and you go from here, oh goodness, I'm going to turn on Snap. And then I'm going to click the point, and I'm going to turn off Snap to Grid again. There we go. And I'm just going to trace this line out. Remember, this is where you'll get the thickness of your fin. There we go. Brilliant, superb. So you can click Finish Sketch. So now we've got these two airfoil surfaces. We're going to join them to our penguin-shaped fin. Next, we press R for a rectangle to start our sketch, and we're going to do it along this plane here, which has our flat section of our fin box. Okay, and then we're going to press Create, Project Include, Intersect, and we're going to choose the airfoil shape of both the top and bottom. So we've got 4 lines selected. And now we're going to use our squiggly line tool, and we're just going to draw along the penguin fin. Take your time with this, I'm just doing it quickly for the video. There we go, and you have to make sure you start and finish at those purple points that appear because you've made the new intersect points. Double click to finish your squiggly line, and then at the top section, this is what matters most, okay, is that you're going to draw this separately. Okay, and you're going to make it in two halves. You're going to make the front and the rear half. So I'm just going to go along here. There we go. I'll join the wing a little bit more. There we go. And you want to make sure that the very highest point is where you double click to make a new line, and then you rejoin the rear up to this point. Okay, double click, and then if you make these straight like so, you can barely see that there was any intersection there. Okay, so now we've got our sketches. I'm just going to remove the canvases, and you can see these two airfoil shapes and then this wing shape. So next what we're going to do is click the bottom airfoil shape, click loft, and then select the top airfoil shape, and you can see you get this wing shape here. But the next point is you need to deselect chain selection just up there, and then you can click this plus icon here, and then you click the front of your wing, and then you click the rear of your wing, and you can see it's filled out just beautifully. Click OK, and then you'll see your sketches disappeared. So you click your sketches, you make it reappear, and you again click create a loft, and then you click the bottom of your wing shape, and then you click the topmost point. Okay, and that is the intersecting point that we made earlier. Again, just ensure that chain selection is off, click the plus icon, click the front, and then click the rear. Click the rear, heartbreak. Okay, so I've got a little bit of a problem with this piece. I think it's just because of how I've designed it, where it goes a bit too far back in one go. So I'm going to quickly go tweak that and then see how it goes from there. For the top section, you want to be able to do this and then click the topmost point, and then click plus on the front and the rear section. However, if it doesn't let you do that, you can also click create and then loft, and you want to just select this and this face, click OK, and the two should merge together. If you put a bit more effort into this than me, then this should look quite nice, and that will make you your fin. If you want to add cant to your fin, so this is the angle that it sticks out at, like that. So I think this is about 7 degrees. A lot is 10 degrees, not much is 0 degrees. Most fins stick around 7. But if you click on this bottom line here, click on move, it will rotate around that section. You can then use this to adjust the cant angle. I'm just going to use 10 degrees for this example. And then you want to remove the fin box. Now, here's an interesting point, is now we have part of the fin sticking down, and that could add some issues later on. So what we're actually going to do is we're going to click this split body button up here, and then click the body itself, and then we're going to select our splitting tool to be this flat piece here. See, it's going to cut it into 2 separate bodies. And then on the bodies section, we now have 2 separate bodies. And all we're going to simply do is remove the bit that we don't want, and then we're going to add back on the futures fin box, and now we have a penguin shaped fin with a futures fin box. You can then export this as an STL. Some key things to think about is the layer height. If you have a really low layer height, it will be more hydrodynamic in the water. However, if you have a higher layer height, you'll get a bit more rigidity and stiffness. So play about with that if you want. In terms of strength, wool loops is quite a key point, I think. So this will define where it would snap. So you can see here, when it's on 20, it doesn't go very far into the actual fin box section. So putting the wool loops on 10, for example, will mean that it should extend down. You can see here, now it goes about halfway into the fin box. I think halfway is pretty good. If you put, for example, 5, then you might find it is too strong, and when it breaks, it might rip out your fin box, and you don't want that. So I would suspect putting it about halfway into the fin box has worked really well for me. You might even want a bit higher number than 10, perhaps 15. On my original fin, I used a wool loops of 20, and that worked pretty well. I think this design here could do with maybe 12. There we go. So I suspect that when it rips, it will rip out along this line here, which means that it will just slide out of half of your fin box. And that will do it. So you can print that. Make sure to dry your filament beforehand. I recommend drying it about 100 degrees on your print bed for maybe 4 hours swap its side halfway through and it should just print fine. I hope this video worked well for you. If you do design a fin, please drop a link to the STL in the comments section, because then other people can kind of go through and check out the cool wacky fin designs that you make. I think a Spitfire wing could be quite a cool fin design. Perhaps a T-Rex skull from the side perspective could be quite cool, or maybe a shark tooth for your side fins. That would be quite neat. Some other things I've been thinking about: if you want to make a center fin, you might have to cut it in half using that splitting body tool and then glue the two halves together. That would work. Another thing I've thought about as well is that if you were to print it, you could then heat it up, and then so it becomes all squidgy and melted, and then you could put it over a curved surface, and then instead of having just pure flat side, you could have it, say, bend halfway through to be like this kind of angle. You can mess about with it, you know. You can add a little whip to the end of the fin. Let me know how it goes. Different thicknesses change how it rotates and twists in the water. So if you have a thick section to the rear, then maybe the front will dig into the wave, or maybe if it's very thick at the front and then thin at the back, then maybe it will only flex at the rear, keeping you a bit more pointed forward. I'd love to hear your experimentation. Perhaps if you want to sand it down, please use a respirator and do it in a really well ventilated area, and look into the safety of sanding carbon fiber filled filaments, because it's not very safe. You could cover it in epoxy for a bit more of a hydrodynamic effect. You could also clear coat it. That would also work for an easy addition to the hydrodynamicness of the fin. But yeah, please drop links. I'd love to see other fin designs. If this works for you, please let me know, because I spent months trying to work out how to do this, and then I spent again today trying to rework out how to do it. So yeah, let me know how it goes.